Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning for the all audience who has joined with these programs. In Rado Institutes, we will try to discuss about the new models based on the techniques alpha power transformation. Alpha power transformation, it means we are trying to give the once more parameter to the all probability model. Okay, our discussion today based on the one's international research article, the nice research article, I think, okay, like this one. We have the one research article published on the Journal of Mathematics and Statistics in the 2024 with the title Alpha Power Inverted Exponentiated Weibull Distribution with Data Application. Based on this research article, we have the equation 6 and equation 5. In this equation 6, we will try to using the concept of the alpha power transformation to create the new density function. We will give the one more parameters, namely alpha, okay, to the new probability model. Okay, of course, in the equation X, we need the density function of the old models and the cumulative distribution function of the old models. So based on the equation 5, we will find the new cumulative distribution function, okay, based on the equation 5. Okay, in this research article, we will use the old density function like the equation 4. We have the three parameters of the density function, namely exponentiated Weibull. We have the three parameters density models, like in the equation 4. And then we have the all of the cumulative distribution function, like in the equation 3. Based on these two equations, equation 3 and 4, we will try to using the equations 5 and 6, and then we will find the new density models, namely alpha power inverted exponentiated Weibull, like in the equation X. In the equation X, we have the 4 parameters, alpha, eta, C, and the phi. Okay, we have the 4 parameters here. Okay, the 4 parameters. And then for the equation 7 is the cumulative of the new density function or the alpha powers inverted exponential Weibull. In this research article, we are very lucky in this research article based on the table 6, we have the 2 data sets. Okay, based on the data 6, we have the 2 data sets. Okay, which one? Okay, wait a minute. This one. In the data, in the table 6, we have the 2 data set. We will try to using the second data to using our the coding program to the estimate the parameter. Okay, for the second data, we have the parameter alpha 32, the second parameter 4.4, and parameter 3, 1.020, and the parameter 4, 2.1. Okay, we will try use the hours R. So let's open our coding R program. Okay. This one is a second data set. We run our second data set and then we check here X. This is our second data set. Okay, by using the create the coding of the log likelihood for the alpha powers inverted exponentiated Weibull. Okay, like this one. Okay. This coding based on the equation X. Okay. I will give the blue colors. Okay. The blue colors, it means this is the equation X or the density of the alpha powers inverted exponentiated Weibull. After we create the log likelihood of this model, we run here, and then we try to using the optim to estimate the parameter. We will give the initial value of the parameter 110, parameter 2 1, parameter 3, 1, and parameter 4, 1. Okay, let's our running our program. Okay, here's we check our program. View. Okay, this one the parameter. The parameter is so very different with the recent article. The first parameter is 35, and the second parameter 5 point blah blah blah, and parameter 3 0.3 blah blah blah, and the parameter 4 20.6 blah blah blah. So we have the different parameter with the parameter of the recent article like this one, the second data. This is parameter of the second data. This is parameter 1, and this parameter 2, and the parameter 3, and the parameter 4. Parameter 4 is a very, very different. So the question is, which one is the best parameter? Okay. To answer this question, we will try to using the concept of the density plot and the cumulative plot. For the first one, we will try to using our parameter based on the optim. And the second coding, we are trying to using the parameter of the recent article. Okay, so this one is density function for our optim. Okay, and this one, this parameter based on the recent article, and this one of the density function based on the recent article. So we will try to using the density plot. Okay, the density plot, it means we are trying to make we will try to capture the histogram of data by the density function of the model by the optim, and then this one, the density function, the parameter based on the recent article. And then after that, we are using the cumulative plot. We will try to capture the cumulative theoretical. Cumulative theoretical, it means we are trying to using the formula I minus 0.5 divide n. I number is 1 until the length data, and n is the length data. And then we try to make the comparison with the cumulative by the optim, and then the cumulative by the recent article. Okay, we will try to our R coding. We check by the density plot and the cumulative plot. Okay, so we try run our program. Okay, we will just waiting until, okay, this one. Okay. Okay, you can find from the density function, we have the green one and red one. Okay, the green one is mean the alpha power inverted exponentiated Weibull by optim, and the red one is the by recent article. So we can check here our parameters by optim is better than parameter based on the recent article. And then based on the cumulative plot like this one, we can find the green one is very closely with the gray ones. Gray one is a cumulative theoretical, and the green one of the cumulative of the alpha power inverted exponentiated Weibull by optim. So based on this graph or the figure of the graph, namely the density plot, the cumulative plot, we can make the conclusions that our parameter based on the optim is better than the recent article based on the recent article. So that why, from our discussion today, we believe that if we have the different parameter with the recent article, is don't worry. You are not make the mistakes. You must check your parameter by the comparison with the parameter by the recent article. Which one is the better? Of course, based on depend on the cumulative plot or the density plot. Okay, I think our discussion today is this nice discussion. Okay, we see you again on another discussion. Assalamualaikum warahmatullahi wabarakatuh.